Our next speaker holds a degree in electrical engineering from the University of Erlangen, and he still is based here in that area. And he's specialized on image communication. He started working as a test engineer at TÜV, and then joined Kunze for 14 years and was responsible for the camera systems in Germany. Since 11 years, he runs his own company, specializing in both standard and advanced solutions, like AI solutions for the light field technology. We're talking about MKey solutions. They are seen as one of the preferred network solution partners for Kunze. So this is where they come together again. And the MKey solutions motto is, your key to a successful management and camera solution. And this, connected with AI, we're going to get the secrets now. Please welcome, let's hear more of the CEO of MKey Solutions, Michael Kunze.
Thank you. Thank you. Yeah, thank you for your warm words. Yeah. Okay, my name is Michael Kunze. I'm the CEO of MKey Solution. I have more than 30 years experience with image processing, image operation, and measuring systems. Our company is focused on these measuring and vision systems. Today, I will speak about the problems for bin picking. If you pick a product, then you must see this product. But what is with the high glare surface? Then you have a problem that you get not a stable information, not a stable 3D information about the points. Typically solutions, as you know, it's for example, is the laser cutting methods. Then you have a laser beam here. Here present a laser line on the object, and the camera with an angle see this profile and can calculate this profile on this step. Then we move this part or the camera, and then we get the next profile, and step by step you get a 3D image. Also, typically the point is that you use this. Well, it doesn't work here. Okay, it's the structured light. If you use a pattern projection or a structured light here, then you can also calculate the difference in the height. And if you need more, or if you use more images with different pattern, with different stripes, then you can also calculate a 3D point cloud, but you need to stop the workpieces to the camera. You have no movement. But the presenter doesn't work. Can you activate? Ah, there, thank you. I hope so. Then we must one step together. Okay, let me go back. Yes, in the practice you see this one here. It's moving up. And how can I start this? No, normally it should start by himself, but it doesn't start here, correct? I hope so that we can. I will wait. Okay. Now I hope it starts by himself, but it doesn't work here. Now you can see this laser line is running through over the workpieces, and this is step by step you get the profile, and then you can calculate the 3D images or other workpiece here. Then with the structured light, then you have many images there, and with all of this image, you can calculate the 3D. That is a typically techniques. You know this is on the market. But what is the result with these shiny surfaces? With the shiny surfaces, you see here, the you have no information about, or no stable information about the surface from your workpiece. Or with the structured light also here, it's missing the information. It's not stable result. Because you have many reflections of your light, the camera have no information where comes the light from. What can we do? I will go to next. What can we do? We can use a spray. Nobody knows this one, but on the fairs we'll use this spray. You bring a small cover on the surface, as 2 or 5 or 3 micrometers, and with this cover you can improve drastically the reflection of the reaction of the surface. Okay, now you can see here. This is the before, and this is after using this spray. Same with the structured light. This spray can improve drastically, but realistic isn't. In the production line, you cannot use such a spray because you have additional material, you change the surface, you cannot weld anymore, or you can mounting this, and therefore it's not a realistic solution. What can we do? We use the new technology, is the light field technology. What is light field technology? If you know the light beam comes from any point, and then you can the coordinates x, y, z of this point, but interesting, where is the direction of the light? You can use 2 plans. One plan, you get the information, where comes the beam from, and the second plane, and then you have the information, what is the direction of the light beam. But in the practice, can we do this? You see here this on this right side. We use many cameras side by side. And then you have 2 planes. The first plane is the pupil of the eyes, and the second plane is the image of the camera by himself. We have many eyes side by side, and all together is one camera. The light field technologies can calculate this direction, and we get also on high reflection surfaces, we get good information about this project. You see a typical camera, many eyes, 13 together. And with this, we can say what is the orientation, what is the 3D geometry of our product. In the practice, you see here, this is the cameras. One row, the other row, in the middle is the same presented, the same camera. But this image is a little bit blurred because we have an NDA with this big customer. And therefore, we cannot show each detail. But what is the result? You can see here the result. We get for each workpiece, we get stable information in the 3D with this high, shiny surface. And this is one good point of the light field technologies. We have a robust solutions also for shiny, early, and other reflected surfaces. And there's the practice, the use cases. This is a typical situation. We have this information here, this point. We make a picture. We analyze this picture in the 2D to reduce the regions that we have increased the time. Then we say in this region which we found was interesting objects, we go to the 3D point cloud. In the point cloud, we're matching to the CAD model, for example. And then with these coordinates, we give to the robot. Yes, this is a simulation here, but of course, it works also in a real robot, which you see here. The robot, now he gets the position, he can grip this point, this workpiece, and bring out. The second example, you see also here, it's a typically aluminum cast part or any other metal with very difficult surfaces, and we go the same situation. We have two detected in 2D and 3D objects, and in the 3D we can matching to a CAD model, and with this information then we can also look for the collisions and whereas the outside, and we give the robot a path. How can you use, or here can you pick this part here from the pin? Okay, the light field technologies gives us a high accuracy, small occlusion also for difficult surfaces. And if you know that we have seen, it's one picture. All eyes makes the picture to the same time. We make one picture, and therefore it's also for objects in movement. Yes, with structured light, with many, many pictures, you must stop the project, or with the laser cutting technologies, you need the movement, but it's the orientation must be the same, and therefore it's a big advantage for the light field technologies. Then we have the many possible applications here. It's the object detection, localization, and also others for pin picking, quality inspection, and object measurement. The light field technologies have the improvement, and this is small, but a main point for your robot application, that the robot must know where is the workpieces, how can I picking these workpieces, and therefore the light field technologies gives us a big advantage. Okay, let's come to the end. And by the way, if the light field technology is a very new technology, therefore, together with the manufacturer of the cameras, Mr. Garber, we have, in the end of the year, we have a special offer that you get, and for your first camera, you get a special prize. That is, if I inform you about this. Thank you.
Thank you very much, MKey.
Thank you.
Do we have any questions here in the audience? Yes, that was really quick. Wow. Gunesh, if you'd be so kind, thank you.
Thank you. Thanks for the talk, very interesting. Seeing all these cameras and all those calculations, does it have an influence on the processing time, or in the end it's as fast or maybe even faster than other systems?
Yeah, we have 2 points. The first point is the image acquisition. This is very speed up. But then you go to the 3D model and the 3D point cloud, and this takes time. We can reduce the time because we go to this 2D image and we say what is the interesting region. Yes, and then we go with the small region. We go to the 3D point cloud. Therefore, we can increase the speed. Yes, and we can decrease the processing time. But this is a very point that we need many, many milliseconds for this step. Yeah.
Okay. Thank you.
Thank you.
Anyone else? Yes, Gunesh, to your left.
So this is used for detection only. It's not used for measurement. So what's the actual resolution of the camera system?
Yeah, the question is what is the base of the cameras and the numbers of the cameras. In the example, we use 13 A's, but you can use more, then can you increase the accuracy. Typically, we have, in these cases here, there's the distance between the camera and the workpieces is 1 meter or 1.5 meter, and the accuracy typically is 0.1, 0.2 millimeters. Yes, that is typically situation, but we must see what is your cases and what we can do is by in our office we can do in MBU, yeah, that we say what is your accuracy.
Thanks.
Okay. Any more questions here in the room? Doesn't seem to be the case. How far away can the camera actually be? How far away can the camera be from whatever it wants to?
Yes, this is an advantage of the light field technologies, because we have many eyes to go in the same direction, and there we can increase the width, yeah, up to 2 meters or 3 meters. It depends on the base. Yes, and one big advantage is the depth. Yes, that we started typically from 0.5 or 1 meter and go to 3 or 4 meters is no problem with the light field technologies in these settings here.
Mm-hmm. And then if the object moves while it's being captured, it's also fine, yeah?
That's one big advantage. If the object is moved, we make one picture, and in the typical situation, in these cases, we have a shutter time of 400 microseconds. Therefore, a high-speed object is no problem for us with this light field technology.
Okay. Well, then, thank you very much, MKey. Enjoy the rest of the conference. And
thank you.
There'll be more time to speak with you later.